Let's go ahead and look at 2.1 through 2.7 review. Now, we covered a lot of new topics in this first part of this chapter, so this review is going to be a little bit longer than some of our other lessons, so just make sure that you're aware of that and you have time to devote to this review when you sit down at a computer. Also, make sure that you have some notebook paper and a pencil in front of you. It's very important that you work these problems out, and you're going to have more problems to work out for this review than you would for a normal lesson because it is a review. All right, let's go ahead and get started. The first thing that we're going to start taking a look at is these types of problems where we have to understand, what does this mean? We have 3 times as many as 7 is 21. And we've talked about something that's really important when we see these problems is identifying what these words mean. When we see times as many as, we can cross that out and we can replace that with a multiplication sign. Is can be replaced with an equal sign. So we could rewrite this problem as 3 times as many as 7 equals or is 21. 3 times as many as 7 is 21. Okay, let's look at another problem when we do the opposite way, when we go from the equation to all of the words. So here we have 5 times 7 equals 35, and when we need to turn it into an expression with words, so our 5 times as many as means multiplication. 5 times what is what? 5 times 7 is 35. So those are pretty simple. It's just a way for us to understand what these different words mean and understand what our expressions mean. I want you to go ahead and solve this problem. Now, something that's really helpful when you're solving these problems is crossing out those words and putting those symbols to help you understand it. I want to know which of these sentences below, A, B, C, or D, is the same as this equation. Go ahead and solve that now. If we were to cross these words out, is equals, times as many as is multiplication. So here we would see 7 equals 5 times 35. Does that make sense? That one does not make sense. So I would put an X through that or a mark next to it. That does not make sense. My next one says 5 is 7 times as many as 35. If I were to rewrite this one, it would have 5 equals 7 times 35. That also does not make sense. My next one says 7 times as many as 5 is 35. So here I have 7 times 5 equals 35. Hey, that looks very similar to what I have up top. 35 equals 5 times 7. That could be my answer. My last one, 5 more than 7 is. More than means addition. So here I would have 5 plus 7 equals 35. And that, of course, does not make sense. So my answer for this problem would be C. And it was relatively easy for me to get this answer if I crossed out those words and put those symbols. Otherwise, you can get tricked with some of these, especially if the order is different than what you see in the problem. Remember, the commutative property tells us that we can have this in any of these orders. We could have 35 equals 5 times 7. We could have 5 times 7 equals 35. Or we could have 7 times 5 equals 35. No matter what order these numbers are in, they mean the same thing. I'm going to get the same result. So be careful when you're solving these problems. All right, next up we have a word problem that we're going to use this same type of multiplication comparison with. All right, John has 12 dogs. This is 6 times as many dogs as Luke. How many dogs does Luke have? Now with this problem, John has 12 dogs. That's what John is equal to. Has means equals. So John has 12 dogs. 12 dogs is 6 times as many as Luke. So 12 dogs is 6 times as many as Luke. And how many does Luke have? Notice when I was able to cross out some of these words, I was able to make this problem really simple. If I rewrite it, I have 12 dogs. That's how many John has. is equal to 6 times Luke. And I'm looking for Luke. I want to know how many dogs does Luke have? I have to think about my multiplication facts. 6 times what equals 12? Well, 6 times 2. So if I rewrote my equation, 12 equals 6 times 2. Luke has 2 dogs. It was that simple because I was able to look at my problem and identify those words. I want you to solve this next one. Mia picked twice as many apples as Jessica at the apple orchard. Jessica picked 7 apples. How many apples did Mia pick? Go ahead and solve this problem. Write an equation, figure out how many Mia picked. All right, Mia picked twice as many as Jessica. Twice is the same as 2, as many as Jessica. Jessica picked 7 apples, so I can replace Jessica here with a 7. And I want to know how many Mia picked. Well, right here I already have my equation. 2 times 7 is going to equal how many Mia picked. Well, what is 2 times 7 equal to? 2 times 7 equals 14. So Mia picked 14 apples. And again, I was able to solve this problem by crossing out some words. I also want you to notice a few things about this problem. Notice it doesn't give me a total here. When I'm doing my next few problems that are comparison problems that I have to draw my models for, it's going to give me a total number. I don't have any totals here. I'm searching for one person, but I'm never given a total, so I can make that multiplication equation pretty easily. For this problem here, again, I wasn't given a total number that they both had. I was just given the number that one person had and had to find the number that the other person had. Let's take a look at our next problem, and this is going to be a multiplication comparison problem where we are going to have to draw a model. So Brady and Ethan collected 24 Tallahassee rocks. Brady collected 3 times more rocks than Ethan. How many rocks has Brady collected? Now notice how it gives me a total here. So they both collected, in total, they've collected 24 rocks. Because I'm given a total, this is where I'm going to have to draw my model. So I have Brady and I have Ethan. And Brady and Ethan have collected a total of 24 rocks. And Brady collected 3 times more rocks than Ethan. So Brady would get 3 boxes and Ethan would get 1. And all of these would have my n's inside. So when I'm solving for n times 4, because there are 4 n's, is going to be equal to 24. I counted up my n's and there were 4 of them. Now I need to think about multiplication. 4 times what gives me 24? I know that 4 times 6 gives me 24. So n is equal to 6. I'm going to replace all these with 6's. And again, when we were talking about our multiplication comparison problems, this was our first step to draw our model. Our second step was to solve for n. Our third step is to go back and actually solve our problem. So I'm going to go back and reread my problem. It says, how many rocks has Brady collected? I'm going to circle Brady in my model, and I see that he has 3 6's. So in order for me to solve for Brady, I know I need to multiply 6 times 3, which means Brady has collected 18 rocks. And that would be my final answer. But notice I have to go through all 3 steps in order to get there. I have to draw my model, I have to solve for n, and then I have to go back, reread my problem, and answer for what I'm looking for. Go ahead and solve this next problem. Emily and Kaylin were playing basketball. Combined, they scored 54 points. Notice how that's both of them. Emily scored 8 times more points than Kaylin. How many points did Kaylin score? Go ahead and solve this problem now. All right, we have Emily and we have Kaylin, and together combined, they scored 54 points. Emily scored 8 times more points than Kaylin, so Emily's going to get 8 boxes. And Kaylin's just going to get 1. All of these would have an n in them, or whatever variable that you choose that you would like to put. And when I count all of my n's together, my equation I would write would be n times 9, or 9 times n, it doesn't matter, equals 54. I have 9 total n's. Then I have to solve for my n. I have to think about my multiplication. 9 times what gives me 54? Well, 9 times 6 gives me 54. So my n is equal to 6, and I'm going to replace it in my model. And now I'm going to go back and reread my question. So this was step 1, draw my model. Step 2 was solve for n. Step 3 is to go back and reread my problem. It says how many points did Kaylin score? So I'm going to go into my model and I'm going to circle Kaylin. And Kaylin's score is pretty easy. Kaylin scored 6 points. I don't have to do any additional work. I just see that there's 1 6 there. So Kaylin scored 6 points. All right, those were all of our comparison problems. After that, we talked about multiplication, and we talked about a few different ways that we can multiply. We used the area model, we're using the expanded form model, and we're using partial products. So we're going to practice all 3 of those models next so that we make sure we have a good understanding of different ways that we can multiply. For this one, I want you to solve using the area model. Draw your rectangle, separate your rectangle, and find the product. I'm going to ask you for the 2 partial products and then your final product. Okay, you should have started out with your rectangle, and you should have split your rectangle into 2 pieces because 37 has 2 place values. For this first box, I would multiply 6 times 30. For this second rectangle, I would have 6 times 7. I would solve to find both of those partial products. So 6 times 30 would give me 180. 6 times 7 would give me 42. And my final step is to add my partial products together. 180 plus 42. Notice how I line my place values up so that I can add them easily. And I get a final product of 222. That's using the area model. I want you to go ahead and practice the area model again with a larger number. This one is 8 times 284. Go ahead and draw your rectangle. There are 3 pieces here, 3 place values, so you're going to separate your rectangle into 3 portions. I'm going to ask you for all 3 partial products, and then I'm going to ask you for your final product. Your rectangle should have looked like this. When we're multiplying for this first rectangle, we would have 8 times 200. The second rectangle would be 8 times 80. And the third rectangle would be 8 times 4. 8 times 200 would give me 1,600. I have 2 zeros here that I can cross out and bring down. I can cross that 0 out. 8 times 8 is 64. And 8 times 3 is 32. Now all I have to do left is add up all of my partial products. Again, notice I lined up my place values, so when I add down, then my tower isn't all tilted and I add incorrectly. And when I add all of my partial products together, I get a final product of 2,272. Okay? That is our area model. We draw our rectangle, we split our rectangle into pieces, and then we solve for each of those pieces to find our partial products. Then we add them all together. The next model that I want you to practice is expanded form. So go ahead and solve this problem using expanded form. If you forget how to use expanded form, go back and look at your notes. If you don't have them in your notes, use the area model first and then pull those pieces apart to find your expanded form method. Okay, this is what you should have to start with expanded form. With expanded form, the first thing that we do is expand our number. and then have our multiplication times that additional number off to the side. So 9 times 1,000 plus 200 plus 80 plus 4. My next step is to distribute my 9 and multiply it by each piece. So here I have 9 times 1,000 plus 9 times 200 plus 9 times 80 plus 9 times 4. And now I'm going to solve each of those pieces to find my partial products. So all these numbers in orange here are my partial products. 9 times 1,000 was 9,000. 9 times 200 is 1,800. 9 times 80 is 720, and 9 times 4 was 36. And my final step is to add. Now, when I'm adding these, I tend to add 2 numbers at a time and then combine them. Just because they're already horizontal, then I don't have to move a whole bunch of numbers around. So that's what I'm going to go ahead and do. It's also pretty easy to do that using mental math when I'm just going to do 2 numbers at a time. My final step is to add both of these numbers together to get my final product. So I'm going to go ahead and do that using mental math as well. I'm starting in my ones place. 6 plus 0 is 6. Then my tens place, I just have a 5. My hundreds place, 7 plus 8 is going to be 1,500. And I don't have anything in my thousands place, so my 1's going to go there, and then my 10,000s place. So that will be my final product, 11,556. This is expanded form. I want you to try one more in expanded form. Go ahead and give this problem a shot in expanded form. 6 times 785. 6 times 785. Because this problem is a little bit smaller, I don't have to expand 4 place values, I just have to expand 3. 6 times 700 plus 80 plus 5. Now I'm going to distribute my 6 and multiply my 6 times 700, my 6 times 80, and my 6 times 5. My next step is to multiply to find my partial products. So I'm going to multiply 6 times 700, then I'm going to multiply 6 times 80, and then I'm going to multiply 6 times 5. So I get 4,200 here plus 480 plus 30. And my final step is to add all of these together. Because I only have 3 numbers, I can use mental math to solve this. I have zeros in my ones place. I have a 3 and an 8 in my tens place, which is going to give me 11. I carry over to my hundreds place, where I have a 4 and a 2 and that 1 more, so that's going to give me 7, and then I have my 4 in my thousands place. So that would be my final answer, 4,710. Now I can check my work with estimating my product. If I were going to go over here and look at 785, that's pretty close to 800. So if I multiply 6 times 800, I get 4,800, which is pretty close to my actual product of 4,710. This tells me I'm in the right direction. My estimate is greater, but that's because I rounded my 785 up to 800, so it should be greater. So my final product is 4,710. Okay, we had one more method that I want you to practice, and that's using partial products. So this is the one that we solve vertically. So we have 6 times 483, and I'm going to lay this problem out for you. This problem should be set up vertically when you're solving it. Solve for your 3 partial products and then find your actual product. Go ahead and do that now. Just like the last 3 methods, we have to start by expanding our number. So 483 gets expanded to 483. My next step would be to distribute my 6, or multiply each piece times my 6. My third step is going to be to multiply to find my partial products. And when you're putting down your partial products, please make sure you're lining up your place values so that you can add down easily. This is probably the easiest method to use when you're actually adding your partial products, because they're all vertical for you guys, and we tend to like adding vertically more than we like adding horizontally. So this way I can add pretty quickly. I don't really have to do anything mentally because it's right there in front of me. And I get 2,898 as my actual product. If I were to round these and just to ensure that I'm doing this correctly and that I'm getting close to the right product, I would round 483 to 500. It's pretty close to 500. 6 times 500 would give me a product of 3,000, or an estimate of 3,000. 3,000 and 2,898 are pretty close. I want you to do one more problem like this. Go ahead and solve this problem using partial products. My first step when I'm using partial products is, of course, to write my problem vertically, and then I'm going to expand my number. So I expanded 1,348 into 1,348, and now I'm going to multiply times my 5, or I'm going to distribute my 5 to each piece. My third step is actually to multiply. Notice how I'm lining up all of my place values so that I can add them easily. And my final step is to add. If you don't line up your place values, it's going to be very challenging for you to add these problems. So please make sure we're lining our place values up. My final product is 6,740. Okay. All right, we have one more problem that I want for you to solve. It's a word problem. Miss Jackson bought 6 gallons of juice for a party. Each gallon has 16 cups. If 3 cups of juice were left over, how many cups did people drink at the party? I'm going to give you a hint. Your first step is to find the total number of cups. So 6 gallons and 16 cups in a gallon. Then, once you find your total, subtract that 3 cups. Do that now. You can solve using any method. The problem that we have to first start off by solving is 6 times 16. I'm going to go ahead and use the area model to solve this. So I have my rectangle. 6 times 10 is going to be 60. And then 6 times 6 gives me 36. Then I need to add my two partial products. 60 plus 36 gives me 96. So this was 96 is the total number of cups that were at the party. Then it says if 3 cups of juice were left, that's how much was left over. We want to know how many did people drink. All we have to do is subtract 3 from our total, and we have 93 cups of juice. So our answer should be D, 93 cups. Okay, that's it for our review. If you found something challenging out of this, you have all of the videos from 1.1 through, or 2.1 through 2.7 that you can go back and rewatch. You can also rewatch them on my YouTube channel so that you can fast forward and get to the part that you need to get to. Please make sure you're reviewing for your quiz and that you understand how we're solving all of these problems. All right, next up, we will be moving on and talking about other ways that we can multiply in 2.8.